Okay, you guys, so as promised, we'll finish off the handout here by looking at some more situations. The next round, we're basically considering the sine, cosine, and tangent of 300 degrees. So again, if I drew a picture of this situation, what's happening is we're all the way over here. So there's roughly a sketch of a 300 degree. In terms of the reference angle, hopefully you guys can almost just feel it. I've already rotated 300, so how much more do I have? It looks like it's going to be 60. Right? Of course, you could also use the formula, right? Let me change colors here. Theta star, right, is 360 minus 300, and there's your 60. So basically, we're talking about a 60-degree reference, and its corresponding right triangle, right, would have a negative y value, or excuse me, let me give them value. Since this is 60, that means right here is 30. So this guy would be a positive 1 because it's on the positive x-axis. This will always be 2, and then this will be negative square roots of 3, right, because we're negative y. So there's my adjacent, there's my opposite, and there's my hypotenuse in the new language, or your x and your y and your r, right, for the situation that's given. We're still embedded that. X is positive, y is negative, r is always positive, it's 2. So now that I've labeled everything in my reference, right, how do I find the sine of 30? Well, again, by theory, right, our sine of 300 is equal to the sine of 60 in that reference triangle area. And so in this case, it's the opposite over the hypotenuse, and the opposite is negative square root of 3. The hypotenuse is 2, so this is square root of 3 over 2, right, the fraction. So there's your exact value of the sine of 300. Cosine of 300, well, again, this will be the same as the cosine of the 60-degree reference for this picture, right? And so by definition, cosine is the adjacent over the hypotenuse. In this picture, the adjacent is 1, the hypotenuse is 2, so there's your value for cosine of 300. It's equal to 1/2. Tangent of 300, well, again, by this theory, the tangent is basically equal to the tangent of 60 degrees for that reference picture, right, for the situation that I have going on in that situation. And so tangent is the opposite over the adjacent. And what we have here is the opposite is negative square root of 3 over 3, and the adjacent is 1. So it's negative square roots of 3, right? So there would be your tangent value of 300 degrees. All right, and so in the next round, I'm now going to be using the other 3. I got cosecant, secant, and cotangent. And then to make my life harder, we're not in that nice full first rotation. So the first thing I need to do before I do anything else is figure out where that is. So negative 390, right, if I add 360 to it, I get negative 30. And you pretty much have your picture right there. So how about I just do this? Negative 390 literally means I'm going to rotate a full rotation and go 30 degrees more. So we actually just stumbled on our reference angle, right? It's 30 degrees. And so here's the corresponding right triangle for it, right? Again, the side opposite, this would be negative 1 because y is negative. This side would be the square root of 3. And that side is always 2. So there's my adjacent, this is my opposite, and this is my hypotenuse respectively for the situation that we have. So we kind of just stumbled on, right, the reference angle just by trying to figure out, right, what do we coterminal to? And so now we're off to the races. So what's the cosecant of negative 390? It's the same as the cosecant of this 30-degree reference situation given by this picture. Again, the picture goes with the reference triangle, or excuse me, the reference angle. Cosecant, by definition, is my hypotenuse, right, over my opposite. All right, it's the reciprocal of sine. In this picture, my hypotenuse is 2, right, and my opposite is negative 1. So it looks like we get a value of negative 2. So what is the cosecant of negative 390? It gives us a value, it gives us an output of negative 2. All right, and so again, using a reference angle, corresponding right triangle. Same thing here, what's the secant of 585? Well, let's take away, right? Let's add subtract 360. We get 5, 2, 2. So 225 degrees. So that puts us in quadrant number 3, right? We're going to rotate here, right? And so there's roughly, of course, 585 meant we rotated once and came around, but it's coterminal to 225. So here, our theta, right? Our theta star, a representative right triangle, we got to figure out what is that guy. And so again, if we rotated 225, this is already 180, so I get a fill it's 45 degrees. Or you just use the formula, right? Theta star would be my angle 225 minus 180. When there's your 45. So we have a 45 degree reference. So the secant of 585 would be the same as a secant of 45 degrees with this picture behind it. All right, again, very, very important. The picture has to have that with it. When I label my picture, everything's negative except for this guy, right? And it's a 45 degrees, so this would be -1, -1, and that's always positive square root of 2. So I have my adjacent, my opposite, my hypotenuse. So now we're ready to go. What's the secant? It's my hypotenuse over my adjacent. In this picture, the hypotenuse is the square root of 2. And the adjacent would be this side right here is -1. So we get negative square roots of 2. So there would be the secant value, the exact secant value, right, for 585 degrees based off of my reference and corresponding right triangles. One more, we have 480. So again, first order of business is let's figure out where this is. So let me take away a rotation, 0, 2, we get 120. So this tells me I have this picture. Let me draw it down here a little bit. So the picture I've got, I'm officially rotating and then going, right, 120 degrees. All right, so it's coterminal to 120 degrees. Now, how do you find that reference angle? Well, either, again, you're just realizing I've already went 120, this is 180, so it's got to be 60, or the formula, right, would be 180 minus 120, which gives you 60. Picture of the representative right triangle, well, this would be the 30, and that's 60, so that one would be -1, again, because we're on the negative x-axis. This would be the square root of 3, and the hypotenuse is always 2, right, for that corresponding right triangle. So I'm just using the 30, 60, 90 right triangle, and then positive or negative depending on where I'm at. X is negative, Y is positive, and R is always positive. So there's our adjacent, there's our opposite, and here's our hypotenuse. So the cotangent, I'm running out of room, is the same thing as the cotangent of our 60 degree reference in this picture, right? And for this picture, what I have for cotangent is the adjacent over the opposite. And so my adjacent is -1. My opposite is the square root of 3. And if I rationalize the denominator, we get negative square roots of 3 over 3. And there would be your exact value for the cotangent to 480. So a lot of work behind it. Tell you the truth, we're still, using an XYR definition. You keep hearing me, right? This one's probably the easiest, right? What's the terminal? What's a point on the terminal side? Well, that point has to be -1, -1 to create that 45 degree reference. So we're still kind of, by the pictures we're drawing, still using X, Y, and R's. But once I draw my reference angle and corresponding right triangle, I now also have the ideas of opposite, adjacents, and hypotenuses, and I've got that new definition in play. And so we can actually find the exact value of many, many, many angles as long as they're quadrantal. That was happened in chapter 1, and as long as they have a 30, 45, 60 degree reference angle. If we've got that, I can actually find the exact value. If they don't, we're going to figure out some other stuff. All right, so that'll come up later in terms of evaluating. Sometimes we just break out our calculators. It's that easy. All right, so let me wrap this up. We've got more things to do with this newfound knowledge. I'll see you in those next videos.